Yeah, so we are live, guys. We can start. Mhm.
Cam, are you ready to get going?
Oh, ready
Yeah,
whenever. If you just want to introduce and do the
yeah.
slide, we can go ahead and get
So,
started.
okay. So, hi everyone. Welcome to another session of DevFest. We'll be having Georgia Smith, a security admin from PCC, and Kevin McGrail, principal at Evangelist Detail. Right? I said that right.
Yes.
Great. Thank you. You're welcome. You can start.
Wonderful. Well, today we're here to talk to you about exporting machines from AWS. This will let you give some freedom to what you're doing on your cloud platforms and kind of avoid things. But first, let me introduce ourselves. So, Georgia.
I'm Georgia Smith. I'm a senior at UVA Wise, which is a small college in Virginia, and currently working at Peregrine Computer Consultants Corporation as a security analyst with Kevin McGraw.
Excellent, excellent. And myself, also known as Cam, I'm the principal evangelist at Dido. And additionally, I do a lot in cybersecurity. My specialty is email security, so that's why I have a can of spam from Canada there. Additionally, I'm a Google Workspace top contributor. I'm also a Google developer expert and an ambassador. I was also the subject matter expert that brought the first U.S. federal agency onto the cloud. So, but that's enough about us. So today, the problem that we're going to talk about is something that we call a roach motel. What that really means is vendor stickiness. So on Amazon's web services, their cloud model, if you spin up a box there, what happens is you can't normally export the instance. There's a couple of reasons you can't. First of all, if you're using software that you get from the Amazon marketplace, if you're using things like Windows or SQL servers we mentioned here, it prevents the export on purpose. Additionally, if you have things like more than one virtual disk or more than one network interface, you also can't export the machine as well. This can cause some problems, especially if you have a very expensive machine or you built something as a prototype and now you want to move it somewhere else, or say you want to move it over to GCP with a lift and shift. So the name Roach Motel is kind of one that's a little confusing, might be an idiom that's particular to the United States. So where the term comes from is a company called Black Flag that makes a bug killer for roaches. And the bug killer had this crazy commercial, which I'll go ahead and play for you.
Black Flag Roach Motel. Roaches check in, but they don't check out. Kill roaches without poison.
So, the roaches check in, but they don't check out was the concept of the Roach Motel. And so that kind of also equates to the concept that, you can spin up boxes on AWS, but you can't check them back out. So that's the basic idea behind why the term Roach Motel instead of vendor stickiness is used. But vendor stickiness isn't necessarily a bad thing. Like I said, Amazon, at least with like the licensing and things like that, they do have to protect that kind of data. But it does prohibit your freedom. And so what we wanted to do is publish this as the solution that we did. Georgia drove a lot of it and really took this idea to task so that we could get a couple of the machines that we had up on AWS out. Some of the things that I want to make sure, I think that's really in the wrong place, but I will mention that the technology we're going to talk about is Clonezilla. There are some significant costs. So this is another part of the Roach Motel that you get. So you'll notice, for example, on a normal bill that we have is about $298. And what's missing on this is that it was $143 in on top of this in data charges. We might have this again, or I'll fix the slide later, but there's a lot of costs. You can see down below, all data transfers in, zero cost. All your data transfers out, as you'll notice, have different costs based on the amount of data that you are doing. So be aware of the fact that there is a cost as well. Again, that's part of the Roach Motel. So with all that, again, I kind of hinted at the fact that we're using Clonezilla as the solution, but I will hand it over to Georgia.
All right, so let's get into the solution, or how to check out of the Roach Motel. So we used Clonezilla, which is an open source solution to cloning. You can go to as many as 40 machines at a single time, I think. So Clonezilla really allows, what we were looking for was the ability to clone to a remote destination. So Kim, you can go ahead and go to the next slide. So what we did is we spun up a Clonezilla machine image in AWS. It was a Debian machine with Clonezilla installed on it. And we had to do that because AWS does not allow you to use ISOs or any live image. So instead of doing the stock Clonezilla live image, we made a machine that just loaded it. Next slide. The other big thing that's very important with this process is the idea of availability zones. To be able to use the volumes you need to use and to clone the volumes in AWS, you have to be in the correct zone, Eastern United States, Mumbai, whatever the zone is, but you also have to be in the correct subnet or availability zone. And these are on step 3 when you configure your instance. And the best way to do this is to do it through the Clonezilla image instead of messing with your original machine that you're trying to clone from. Next slide. The other big thing to notice is Clonezilla has to have certain ports open on AWS. And even if you open these inside of your machine, Amazon might not necessarily allow them to go through their firewall. So you need to configure your security group or your machine in EC2 to have all 4 of these ports open, as well as port 22, so you can actually access the machine. Slide. Clonezilla AMI is what we chose to do because it allowed us to easily access a different availability zone for a different machine. And it was, they're very easy to spin up. So it's something to do if you're going to be migrating more than one machine from AWS. Next. So the first migration we did was a Linux box. Next slide. We did a CentOS 7 machine from AWS Marketplace. Even though CentOS is open source, you cannot export natively anything from the AWS Marketplace. So we decided to go the Clonezilla route. We just gave it 8 gigabytes of magnetic storage, and we ensured it was in the same availability zone. And the only security group that this machine would need is SSH for you to access it, but it wouldn't need anything for the actual migration because that machine is not even going to be used. Only its volume is going to be used. Next slide. So a big thing you want to do, especially when you're going to be putting it on something like ESXI or something where you're going to be directly accessing the machine, is make sure you have a password and sudo access. Amazon does not natively give any users a password. It's just with a key. So make sure you add a password to be able to access that machine before you clone it, which should happen if you're migrating machines that already exist and are being used. But we did a lot of just bare metal machines. Next. The next step is to turn off all of the instances. The Clonezilla instance that we talked about in the previous step, and the instance that you are going to be cloning. And then this way, you can attach the volumes to the Clonezilla instance. Next slide. So Amazon works with volumes and machines. And so the main way that this method works is to attach the machine to be cloned to the Clonezilla machine. And it's very easy to do. You can attach it anywhere onto a machine. You can attach it to SDC. We use the default SDF, very simple, and Clonezilla will automatically identify it. The other big thing is to name your volumes and instances. Otherwise, this step can get very, very tricky. It's a good habit to do anyway, It allows you to keep a much better profile of what volumes you have, because Amazon does not always delete the volumes when instances are deleted. So it's just a good habit to get into anyway.
Yeah, and I would point out down in the attached volume thing, you can see that the name of the volume, for example, normally would be vol dash in a whole bunch of strings, and then you can see the actual instance you can see is like I-097, but in those parentheses, you'll see that we named it GDG dev CentOS 7 and the Clonezilla image or instance. So it was very clear which instances were what, which volumes were what, and this helps, as you mentioned, with the long-term maintenance of machines anyway, just to make sure you're doing things correctly and you're working with the right volume. Next slide, I assume.
Yep.
Okay.
Next thing is to prepare your destination machine, so what you're going to be cloning to. Best results, the minimum specifications, and you can just really easily Google, t2.micro and figure out what those specifications are on AWS, so you can either configure your VM with it or match whatever you're going to be cloning to if you'd like. Next slide. So we cloned to a VMware ESXI. It's a really great tool. And so this is the CentOS 7 box that we cloned to, and it will have all of the same specifications with its memory, CPUs, and storage. Next slide. So the next thing is to load an ISO on your destination machine. So we chose a live image of Clonezilla. Now you could reverse engineer this onto to do it onto a volume similarly as you could attach a volume to an instance where Clonezilla was installed rather than a live image. But the really helpful part about Clonezilla is it automatically configures things like boot records and other parts of the machine that may not be altered. So this live image was just very useful and made it very streamlined process.
Yeah, and if you're not using something like ESXi, where you can just load an ISO as the CD on the machine, there's great tools out there like Etcher. There's Rufus that can take that ISO and burn a bootable ISO to a USB stick. So if you're instead running this on a machine rather than a virtual machine, that would be two great tools for you.
Next slide. So, and then this is the specific steps in Clonezilla. So from the source machine on Amazon Web Services, you want to choose remote source. And that can be confusing because in my brain, I feel like I should choose remote destination, but you're going to enter the source mode. So it's just something you got to get into the habit of remembering if you're going to be doing this.
Yeah, and these instructions will all be posted. Asher will share the link for you. But I have to go do this all the time. I always forget and get them backwards as well. So Georgia is absolutely right about that. All right. Anything else you wanted to say? I'm sorry when I interrupted you. I thought you were done.
You're fine. I am done. Next slide. And then we just use the beginner mode. If you're more advanced in Clonezilla, that is not something you have to stick to. But with the beginner mode, it's just very simple. And then you choose disk to remote disk, and it will clone the entire disk over. Next slide. And as you see, Clonezilla, I loaded it into SDF, and because CentOS, not CentOS, but the Debian instance machine used XV, but it automatically realized that volume was loaded there, and so you just choose that. You can check your files, but I just ran skip file checking because I knew there wasn't anything corrupted in the disk, and because Clonezilla can also be very helpful with disaster recovery. That's a really important step if you're doing something with that. It wasn't really useful for what we were doing. Next step. And I always choose the choose option so that if anything is gone wrong, I can always go into the command line The other important step is to always remember to press enter to continue once you've finished all of these steps, because I have been in the place where I have chosen the option to choose whether to reboot or not and forgot to press enter to continue and could not get Clonezilla to connect to the other machine. So just keep going until it stops.
Yeah, and another quick note is that if you try and connect to it and something happens or anything like that, you have to restart the source over again. You can't. It won't connect twice. It'll only connect once. So if something happens, your connection's interrupted or whatever, or something just doesn't work right, make sure you restart the source and hit enter, as she said, is very, very important. That'll save some time and frustration.
And so this is going to be what you see when you get to the destination machine and you load that live image, just your basic Linux boot screen, and you will just choose Clonezilla Live. Next slide. And this time you choose remote destination instead of remote source. Next slide. Now you're going to have to go in and pull your IP address from your Clonezilla server, or your host name if you have a host name set up. And you should probably already have this very easy access to it. And then you just plug that in and it automatically connects you to the AWS instance of Clonezilla. Next slide. And now this is a very important part. Make sure you really read these things before you do it, because the live image will erase the entire drive of the destination. Now that's the goal. You're going to be migrating to it, but warnings like these and reading these through 100% is very important. So I just wanted to touch on that.
Yeah, at Peregrine, one of the things we do is we actually require 2 people to do this, and 1 person to read it and another person to acknowledge that it's okay to do for any production systems, because it's just it's too easy to do the wrong disk, and you know, if you're like me and you mixed up the source and the destination, you just wrote over the production server instead of copied it across the internet. So absolutely right to take a bit of time, read this, think about it, make sure you've got the system set up right. These slides will be out there. Use them as a checklist, et cetera, that you've gone through the steps one by one by one.
And it's officially cloning. Once you reach this screen, Clonezilla is writing the blocks, and with the 8 GB machine, granted it was just freshly loaded, so there wasn't much on it, but it took about 4 minutes to transfer all the way. And with the next machine, the Windows server, I'll go into that one next, so we can just continue. And when you choose the choose option, as I mentioned earlier, this is what the screen comes up when you finish. So I can enter the command line and make sure everything's fine. But usually I just choose reboot and load it up into the freshly migrated install. Now, when you load a Linux, when you migrate a Linux box off of AWS, there are a lot of artifacts. That VMXNet 3 that you see is where the screen stalled for me when I was using ESXI for, as you can see, 5 minutes. The second picture is the output of systemd analyze blame, and that just is showing you what's happening at boot. So the cloud-init service was running for over 4 minutes, and I've had it run for upwards of 10 minutes before on these migrations. So Amazon does leave artifacts that need to be gotten rid of. Next slide.
Sorry, trying to find my keyboard. There you go.
So the first thing is, as you can see, there are 3
interface configurations.
Thank you. There are 3 interface configurations, but only 2 interfaces. So that ifconfig ETH0 is left over from Amazon, and if the cloud-init is trying to connect it to, I think it's DHCP is what it's configured to. So the first thing is just to simply delete that configuration. Next slide.
Yeah, and that actually might change depending on, this, that would be how ESXi would present the Ethernet card, but if you put it on bare metal, it might come up differently and whatnot. That's somewhat machine dependent, but the key point is you'll have to fix the interfaces.
The next thing is the resolv.conf has an EC2 internal and an incorrect name server. And both of these are private to AWS. And since you're no longer on AWS, it doesn't matter. Also, you might not need the search pccc.com, whatever your domain is, that would be what you would put there. And to keep this from changing at each reboot, you just add peer DNS equals no into your configuration that we talked about earlier. Next slide. Next thing is to just remove cloud-init. And if you're not using a CentOS box, use apt, but you just, whatever your package manager is, remove cloud-init. And then, go to the next slide. Problem is solved. Cloud.init is not stalling anymore, and network service takes about 3 seconds to get up and running.
Yay!
The next thing we did was migrate a Windows box. So next slide. We did a Windows 2019 server, gave it 30 gigabytes of magnetic storage. We have tried this also with the Windows 2012 server, which Cam will touch on in a little bit. Next slide. So the biggest thing with the Windows box is to make sure you get the credentials. If you're spinning up a Windows box on AWS, or you're trying to migrate a Windows box on AWS, you probably already have the credentials, but the simplest way to get the credentials for a Windows box on AWS is to click connect on your instance dashboard, and you will just really be easily able to get your password by following the prompts there. Next. And so migration is pretty much the same. You follow the same steps as I talked about previously, and then you can configure the network how you like. It does not run into the same boot problems as the Linux machine did. But you will need to know your IP for RDP or set a static IP. And this box, just the stock Windows box, when I migrated it, it took about, I'd say about 30 to 45 minutes. So that was pretty good for coming out of AWS. Slide.
All right, I think it's my turn now. So some of the stuff I wanted to talk about here is the final thoughts. This is some of the things that we learned, and also just kind of give you some guidance on this. This is a process we found really amazing. It let us get some boxes out of AWS that we built as prototypes, and we didn't want to be on AWS forever. The cloud is amazing, but sometimes it can be pretty expensive, and there are some problems that you can have. So I talked a little bit before about the fact that you do have to pay for every gigabyte you move out, and that can get expensive. Additionally, we found some issues. So for example, with the Windows 2012 machine, we found it repeating, just constantly bombing out on partition 1. We found a pretty easy solution, which was you just clone it as normal, everything that you just saw here, and what will happen is it will bomb out after partition 2. And you can simply go back, repeat the entire process, but instead of choosing disk to remote disk, you choose disk to remote partition, or excuse me, partition to remote partition. And you just pick the next partition or the third partition and add them. Clonezilla has already built the partition table for you from the initial disk to disk. And so you can just add the other partitions, works perfectly, very nicely. It's just a little frustrating that it bombs out. We've brought this up to the Clonezilla team, and they haven't been able to repeat it like we were, but we did repeat it, I think, dozens of times. That's probably a lot of where that $143 of transfer gigabytes came from. So another thing, if you're in this situation, there are ways to avoid it to begin with. And so, as you saw that, you can't export out if you use the marketplace. So there are some neat ways. So like, for example, if you're like us and you're a big Linux house, spin your boxes up locally. Spin them up in VMware ESXI, which is a free tool. Or you can do a virtual box and then export the virtual machines from there and import them into the cloud. If you build them there, you're allowed to export them back out, no problems whatsoever. You can use the native export tools, and you won't have to jump through all these hurdles. They aren't bad, and Clonezilla is really an amazing open source tool, but this will avoid it, from the onset. Additionally, something to mention, this doesn't get around licensing. So if you export a Windows box that's running up on AWS that's licensed, eventually, sometimes I saw it almost immediately, sometimes it took a week or two, the box will come up and say that it isn't licensed. So this doesn't get rid of any licensing concerns. You'll need to make sure you have the licenses for Windows, because you'll need to reactivate what you're working with, and things like that. So if you're using something that's licensed on an hourly cost from the provider, you'll need to make sure that's taken care of. But if you are doing something like a lift and shift from AWS up to GCP, you're probably preparing for that and whatnot, and this will help you do that. Additionally, one of the big things I do mention is that there are a lot of great pros and cons with the cloud, but there's three main types of data centers that we like to make sure we mention. So there's completely managed instances like AWS and GCP. There's semi-managed instances like zColo and things like that will let you in, but they'll go do remote eyes and ears on the phone with the devices as well. And then there's just what we call ping, pipe, and power, where all they do is they give you a rack, they give you a place to put your own machines in, etc. And all of those have their place. I think people are forgetting that right now. And there's a lot of different costs associated with those three levels of different types of data centers. And different levels of expertise. And the ease of just pushing a button and spinning up a box is something we're going to talk about that's a little bit of a problem. But you do have tools that you can use, like ESXI for running things on premise. That's a great way to use the cloud and these data centers. So Peregrine, for example, uses all three. We have a data center, we have Zayo, we have Cogent, we have our own data center, and we use GCP and AWS. So we have the freedom to use whichever is the right hammer for the right job. And there's also Anthos. We're not rich enough to use Anthos yet. That's a very expensive monthly, but that's a great thing where you can build containers and move them between on-prem and up into GCP and back. So the concept of Anthos is to let you build containers that are agnostic to where you run them. So Google has definitely recognized this as a long-term goal for a lot of companies. Sorry, I'm trying to get to the next slide. But the big thing that I want to talk about here is the total cost of ownership. So one of the number one things is that you still need to administer those boxes. They still got to have patches installed on them. Somebody's got to log in, manage the users, whatever has to happen, make sure backups are done. And we've seen some pretty big problems with this in general with the cloud, because it's so easy to ramp up boxes. So many years ago, over 25 years ago, we did a study, and we determined that a one single full-time IT administrator could do 55 points of work. So we modeled this after a Richard Simmons kind of like weight loss guideline was the inspiration for the concept. And basically, you could hand an IT person 55 cards, and they could then decide what they were going to do with those 55 cards. We actually have a couple more other things like printers and backup management and things like that that are in here as well. But they let them manage what they take on in their work. And so, for example, as I mentioned, one full-time administrator, every workstation counts as 1 point. Every server counts as 5 points. And one of the interesting things is that a virtual server, it's easier to run. You don't have to manage the hardware and whatnot, but it still counts as 4 points. So what this means is, say, for example, you go into a company and there's 50 people who work there and they have one server, that's 55 points. That is a good match for a single full-time person. They're not going to be overwhelmed. They're going to be able to handle that. However, you start adding a couple more servers, a couple more workstations, you're going to have to start thinking about hiring another administrator. What unfortunately doesn't happen very often is that second administrator or more administrators get hired. And so the things start slipping. Backups don't get done, security patches don't get done, general maintenance doesn't get done. Additionally, because virtual servers are so easy to ramp up, people just ramp them up. I've done audits, we do security work and whatnot, where we've come in and seen literally one server for every person at a company. So a 25-person company with literally 25 virtual servers ramped up. And if you think about it from this point system, that's 125 points. So that's over 2.5, or that's closing in on needing 2 full-time and a part-time administrator. And you find out there's only one administrator, and that's when you find out that, the things aren't happening that need to happen. The backups aren't happening, the patching isn't happening, et cetera. The maintenance, the documentation, et cetera. So in addition to that, there's also a lot in the cloud hosting field that is what we refer to as death by paper cuts. That just means tiny little cuts that add up over time. One of the main ones is that if you're using things like AWS, they will try and default you using solid state drives, which are much more expensive. Depending on what you're doing, you might not need the I/O ops or the performance capabilities of a solid state drive. Additionally, if you're doing a lot of writes, the magnetic drives can actually be faster. So you just really have to choose the right thing. But if you're going for low cost, you want to make sure that you're choosing a magnetic drive. Additionally, one of the things that I make sure is done is that any boxes that are ramped up, they're documented, they're named, the volumes are named, backups are set up, etc. Because otherwise, Georgia and people like that, every few weeks, we have to go in and audit and go, hey, there's 4 extra volumes. Nobody has any idea what they're for. Can they be deleted? And you have to pay for all that storage and all those machines that are ramped up. And I actually have a customer right now that has so many machines booted that they don't know what they are, that they're probably paying in excess of $500,000 a month on extra machines. They don't know what's there, and they're afraid to turn them off. So these type of situations can get out of hand very, very quickly, especially if you develop your own products or use any type of continuous integration, things like that. It's very easy to ramp up a lot of boxes, have no idea what they're for, and then have to spend a lot of time trying to figure out what they're doing with extra costs like that. So that's paper cut number 1. Cut number 2 is based on the product details. So if you look at the pricing for a lot of these services, they're based on the per hour. So like, for example, in here, a T2 large is 0.0928 cents on demand per hour for the price for us in our zone from Amazon. And the question I normally ask people is, how much is that 0.0928 cents per hour per month? And a lot of people are pretty surprised to find out that that's about $70. So, they give you a price, if you go back and look at this, that doesn't really equate to real money. It just, that's a penny. That's not much money. But, it's a penny that adds up because it's per hour. And then if you ramp up 1,000 machines and things like that, it's 1,000 pennies per hour. So these numbers add up pretty quickly. And in fact, if you think about it, that T2 large machine, or excuse me, T2 large, about 10 cents an hour and $70 a month. Well, that's $840 a year. That might be a great price, but if you need something more powerful, like the X2 or the 2X large, for example, and you're paying 37 cents, all of a sudden you're at 4 times that cost. And you might find that, hey, that's the time you want to start adding to your cloud infrastructure by doing a ping pipe and power data center in addition to the cloud services. So cloud services are amazing for augmenting services, for using the AI models that they have that they can bring to bear. So we do a lot of great stuff with GCP and hybrid solutions from on-prem to general clouds and to using the cloud as well. That can really save a lot of money, streamline your services. And I kind of miss the old days where you had to do a purchase order to buy a server. It was very expensive. You had to get approval. Right now, a lot of times that approval process isn't there. People can just launch a box without any real oversight. And if they're not brought in and showed the bill, they won't understand the problem. And that does remind me, we did have a problem on that bill. So let's go up and see if we can fix that right now. So we have the cost to export. So somehow I think I do mean we messed up the crop on this. So we'll go ahead and fix that. Yep. So if you see there, it was $140.47. So we got a bill for $298, which is the normal bill for us up on AWS for a couple of boxes. But just doing that data migration out, we spent $140 on data transfer. So it can be very, very, very pricey. All right, let's get back down and finish my last of my thoughts, and then we can take some questions and answers. Let's see where I'm. I think I got to there. Yep. All right. So, oh yeah, that was everything. Thanks so much. The slides, Asher will give you the link, so you don't have to write this down wildly, but it'll be up on migrate.com under the downloads. I'm also on LinkedIn. I love talking to people out there. So if you reach out to me and mention that you heard this talk here, I am very inclined to talk to you, answer questions, bounce ideas, figure out how I can help you and stuff. And I can't speak for Georgia. I'll let her speak for herself on the LinkedIn stuff.
My link. I need to update my LinkedIn, but that's my link. So
excellent. Yeah, I think it still doesn't even have the stuff from a year ago. All right, well, I'll go ahead and stop the share here, and let's see if I can go. There I am back. Okay, so I see some comments over here, so we'll start with them. Lots of hellos, and where the slides, and then great things and noted. Okay, Asher, are there any questions over on the YouTube stream?
So there are no questions. Also on Discord, I was checking out. I did not see any questions. I would love to appreciate you for taking your time and taking us through AWS, how to export the machines. I have learned so much. Also, I think given that they have your LinkedIn accounts, if they have any questions, they'll pin you directly on your LinkedIn, if that's okay with you guys.
All right. Cool. Okay. Bye, everybody.
Thank you so much, and have a happy weekend again. Bye. So hi Janice, adding you to the stream. Hi. Your microphone is on mute.
Sorry, I forgot. Hi.
Happens a lot. Hi.
Hi, how are you guys?
Doing well. How are you doing?
I'm well, thank you.
Great. You can start and give us a brief introduction about yourself and more. Yes.
Sorry, I think my internet was fluctuating.
Okay. Are you back now?
Yeah, I'm here.
We're still live.
Yeah.
Great to have you. Interested to see the session ahead. You can start.
All right, okay, let me share my screen.
Okay.
Can you see my screen? I'm not sure if you guys can. Can you?
I can't see your screen yet. Okay.
Can you see my screen? Okay, so again, hi guys. Thank you for having me. Thank you again for inviting me to speak today. I am very honored. It's my first time attending GDG Nairobi, Fest Kenya, and this has been very informative. Thank you to the organizers as well for inviting me. I am
Uh, I think there's a struggle with your internet, Janice.
Yeah, hi.
Hang on.
I can hear you, but I can't see your screen. I don't know.
I think she has dropped off completely.
All right, all right. Probably you could give us some time to rejoin. Yeah.
Yes.
All right. Okay. Let me do this then.
Hi. Hi, welcome back. Thanks for joining. I could just
Hello.
help you share the screen. Don't really worry about it. Uh, if you check at the other tab, you could see Leave Studio, then Invite, then Share Screen. Sure, I
Can you
can see
see
your
me?
screen. Yes.
Okay.
Nice. Perfect. All right. Thank you.
All right. Let me start over. Sorry, guys, for the facturations. Um, Again, thank you guys so much for being here today. Again, my name is Janice Stefan. I'm a co-organizer of GDG DAR, which is in Tanzania. Thank you for having me here today. And today I'm going to talk about building maintainable software. Um, if I can start with pointing out a scenario that most of us must have gone through as developers. Many times when you code something and then after a few months you can go back and find out that you don't really know what you did, or you don't really understand your code, or another developer will come and they don't get it, or you deploy one thing and then break another. This is can all be summed up as I quote Mr. O'Reilly says, premature optimization is the root of all evil in programming, which means that if we do not take care of optimization in the first place or maintenance, it will come to hurt us later. So, what is maintainable software? What is a maintainable software? A maintainable software will be one that is scalable. That means you'll be able to add more features, fix bugs. Another developer will be able to add features as well without breaking something else. You'll be able to fix one thing and the whole software will still be in one patch. And transparent. A maintainable software has to be transparent, which means it should be understandable to everyone. You cannot be the only one who understands your code, or you only understand your code today at this point. You need to understand your code
I'm sorry, I think we are having slight technical issues. We'll be back in a few minutes. Just keep in touch.
Hi guys, again.
Hi.
Hi, so let me continue where I left off. I was talking about what is maintainable software in the first place. Maintainable software is one that is scalable. Obviously, you should be able to add features, fix bugs, add new things, and be able to scale it up and make the software grow or stretch without breaking other parts of the software. This is really important because when you make a software today or an application today, obviously you expect for it to grow and extend to be able to build in other features or do other things. But if it's not maintainable, that will be a very difficult process to do. Another feature, it should be transparent, which means that you should be able to understand your code today the same way you understand it 3 months ago. Or if another developer comes in, they should also be able to understand what you wrote. Like your code should be very visible and very readable. As I say, good code is one that is written in a way that everybody can understand. Also, it should be optimizable. That means it should be able to grow in order to fit new resources or new environments that are made as as um, as the requirements come. So, what happens if your software is not maintainable? What can you expect? First of all, you can expect you'll spend a lot of time being able fixing bugs, adding new features, finding bugs, because you will not know where the bug is. It will not be a direct process being able to find it. And this is what we call technical debt, and it is paid with interest, just like financial debt. You will be using more time and more resources trying to figure out what to fix or where to fix it instead of using that time to develop the software or develop into something nicer or bigger and better. Also, there'll be more team effort that will be used because there'll be, instead of one developer working on this, 2 or 3 developers will be working on it, just trying to figure out what did the other developer do or what did we do 3 months ago in order, to add something else without breaking the whole thing. And this also affects if you're doing open source softwares, because if I'm putting a software out there for people to contribute to it, they should be able to understand it. They should be able to know what I did, what functions does what and what does not do what. But if it's not understandable, the likeliness of people joining to that will be very low. And we don't want that, because if you put your software out there, it should be able to impact or be usable in many areas and obviously stay for a long time or be usable for a long time. And for that, it will need maintenance. But if that process is a headache, not many people will be able to take it up. Same case for disposable software that we make as personal projects. I might make something today, just out of the blue because I thought of it. And after 5 months, someone will come and be like, I need this or I need to make this. And then you're like, I already have that. But then you come back to it and you're like, what did I do? What does this code mean? Or what does this function do? you don't really get it. So instead of using that time to use the software or actually increase it or make it more efficient to do now what the other person wants it to do, you'll be using that time just trying to understand what you did before. So this all adds up, and maintaining such softwares uses 5 times the effort than developing that software. And that effort comes in money, in resources, in time, in developers that are there, in client trust, because your clients will be expecting, if I report something today, I would expect it to be fixed without it breaking something else. But if it's always breaking and doing this and you're patching it up, it will ruin the client trust. So it all adds up to this one big thing that we don't really want as developers, or international developers that we want to be. So how can we do this, or how can we make this better? There are a number of things that you can do during the development stage, not just during maintenance. The first thing will be documentation. We really have to learn to document the softwares that we make. Document, not just document it, but also document it in a proper way. If I make it today, and I come back to it in 3 months and realize that the documentation doesn't really work, or it's not as understandable, you should, develop it and make it better. Another thing we can do is commenting. Commenting is actually just as important as learning to code, because not just for you, but also for other developers. And for something to grow, you need more people to be able to grow it. So if you put a comment and you'll be like, this just fixes the download bug, only you know the download bug, but nobody else does. Or if you put acronyms that people don't understand but you, it becomes a headache for somebody else. So, and not just for somebody else, but also to the future you. So we really have to learn to comment, and the more you practice, the more you'll get better. Also, we need to learn automated testing, where you make a test for each and every function that you put in your code. This really helps in just knowing that each function works as it's supposed to be, and you get to know this right before you continue with. Like when the software is still small, not when you have this huge thing and you have to find where each bug comes from. If you have tests for each and every function or each and every case in the software, it's easier to find the bugs and it's easier to improve the features as well. Peer code review, you can just get a developer buddy and they will go across your code. This has actually been proven to reduce the number of errors in code right before it goes to production. So the headaches that you're going to get when the software is in production have greatly reduced, because you have more than one person looking at what you did. Code refactoring is also very good, because you'll be able to improve what your code did, what it was supposed to do, without really changing the functionality. And this helps a lot in resources. You'll be saving the resources and time that you were supposed to do what you wanted to do. And version control is very important. Version control as well. And when it comes to version control, it's not just the version of the software only, but also the database configurations, the APIs that are there, all these other logics or business processes that we're supposed to put that came up in each and every stage should all be put together in one version. We often forget to put all these other ones. So, and I would think it's mostly because these are all done in different teams, but in the end, it comes and affects the developer directly. So it's really important to insist, even with the other teams, to put these versions together in one version. So where was I? Oh, it's really sorry. Where was I? It's really important to put version control on all that is involved with software while building it. So there are a number of, so I understand that most of these things usually take a lot of time. That is why most of us do not do them, though we are supposed to do them. And there's always sprints when it comes to developing. But now we have a number of tools that can be used to make this work easier. There's test-driven development, which has been done for a really long time, and it is a very good method of development that can really help us. But then again, it takes time. So we have tools like Just Code, which you can use for code refactoring. It's a Visual Studio attachment where you can put your code and it will analyze it and develop it or refactor it into something better that uses less resources or it's faster. Also, Deoxygen, it can use to document and you can connect it directly to your source code. So it documents what you have from the source code. Also, we have Git and Liquibase. Liquibase is for database version control. Git, I'm sure we're all familiar with it. Jenkins as well, it can be used to build and build, deploy, and test your software before you put it out there. So whatever compilation errors that you ignored before will be caught here and they will be dealt with before you go to production. Software also now for people that, or you're already there and your software has that, what can we do? So for now, you can identify the error-prone areas where you know if you go through your code, you can see that this area is more likely to bring an error in down the road. And obviously, you have to buy a little bit of time for you to be able to go through different lines of that code. But eventually, this will save time in the future. Also eliminating dead code. We know that there's code will be there and it's just filling up the space, but not really adding anything to the software. Also, we also need to take responsibility, as I said before, just, tell the DBA to make sure this is all in version control. All the people who are aligned, us ourselves, should be able to make sure that everything is documented well and we're following good coding practices. So there are a number of things to ask ourselves just to make sure that our code, our software is actually maintainable. We can ask if the code is related. Can you actually find code that is related to a specific problem? Like something is happening, but can you easily find code that is related to that? How easily can you fix it? Can you actually understand what you find there? The logic that is there. Is it easy to change that code? And if you change it, how many features are being, you know, impacted or affected by that? And how quickly can you solve all that? So these are all things we can ask ourselves and act on them just to make sure that the code, that the software that we later build is on point. So that is it for me. Thank you guys so much. I'm sorry for all the glitches. Thank you. I don't know if we have any questions.
Thank you so much, Janice. I think I'm looking through for questions that have been asked by people. Just anyone on live, feel free to add a question on the comments. I can see Steve Hines says, thank you, Janice. Also, I think my question would be, How often do you check your code to make sure that doesn't give you a lot of technical debt?
I would say you need to check it during the development stage, like as you go while developing. If you develop a specific function, you should be able to check it or test it to see if it actually does what it's supposed to do and if the code actually works and it's readable to everyone. So it's better to do it in small chunks than while you're developing than when it's this huge system that has been running for 6 years and there is so much on it. It's
So it's
easier
a
to do
process
it,
down during development.
yes, than when you're maintaining.
Thank you. Any other questions from the people on live? Uh, I think there is no other question. Thank you so much, Janice, for your time. That was a really great discussion. I loved what I heard. Thank you so
Thank,
much.
thank you. I'm glad. Okay, bye.
Bye.